This section is on apportionment paradoxes. So these are some issues that can arise with the apportionment methods. So the first is the Alabama paradox, which is a scenario when reapportionment after an increase in the total number of representatives to be apportioned causes a state to lose a current representative. Number 1 says, consider the apportionment of 28 digital projectors for a school district with 4 campus locations labeled A, B, C, and D. Use Hamilton's method to complete the following apportionment of the projectors. Suppose the number of projectors to be apportioned increases from 28 to 29. Use Hamilton's method again. Will the Alabama paradox occur? So as you can see, I've worked through Hamilton's method off screen. So Campus A is getting 4 projectors, Campus B is getting 9 projectors, Campus C is getting 2 projectors, and Campus D is getting 13 projectors. So now the number of projectors increases from 28 to 29, which means we need to reapportion them, which means we need to run through Hamilton's method again. And as you can see, I've already done this. So Campus A is getting 4 projectors, Campus B is getting 10, Campus C is getting 1, and Campus D is getting 14. So now it asks, does the Alabama paradox occur? And for the Alabama paradox to occur, a campus needs to lose a projector after the reapportionment. So Campus A went from 4 to 4. Campus B went from 9 to 10. Campus C went from 2 down to 1. And Campus D went from 13 to 14. So yes, the Alabama paradox has occurred because Campus C lost 1 projector when it changed from 28 to 29.